My name is Niall McKay and welcome to Living with PSC, a podcast about the rare disease of primary sclerosing cholangitis. Now, PSC causes the bile ducts inside and outside the liver to become scarred, narrowed and eventually blocked, and leads to liver cirrhosis. In this podcast, we aim to dispel some of the myths about the disease. Today we're talking to Dr. Heather Francis, who is an associate professor at Texas A&M University. We're talking today about URSO and some of the startling effects that Dr. Francis has found in studies where they combine URSO with over-the-counter antihistamines. Welcome, Dr. Heather Francis. We're delighted to talk to you about URSO today. Dr. Francis, do you want to tell us what your position there at Texas A&M is?
Sure. Thank you so much for having me speak to you guys. So I am an associate professor at Texas A&M Health Science Center College of Medicine. And this is a basic science department filled with different types of investigators looking at, for example, the liver or heart disease or vascular dysfunction. And the whole department is made up of basic scientists.
And do you treat patients as well, or is it mostly research?
No, I'm strictly research. I have a PhD, so I'm not an MD. I'm only involved in bench level research. Oh, great. Well, thank you very much for joining us. Now, there's not many controversies in the PSC community, but URSO happens to be one of them. Do you want to tell us a little bit about the drug and how it works? So what we know about URSO or UDCA is that in some patients, it can reduce inflammation. Chemically, it has been shown to be able to work with nuclear receptors like FXR that can have a positive or negative effect on liver injury. And in our particular study, we sort of looked at it in a different way. But as far as patients go, I'm sure, as you know, some patients will respond to URSO treatment, but it's still very controversial, especially here in the United States. I think that doctors are a little more pessimistic about giving that to some of the patients that present with PSC. And there may be some very specific reasons for that: genetic, different lifestyles. I think that it could be a multitude of things about why some patients respond and some patients don't.
Oh, I see.
And this is a bile acid. So, it's a drug that can be used to, like I said, stimulate different signaling pathways that can have different effects depending on the disease.
Now, how does it work? It's basically, and where does it come from? Is it manufactured, or how do you synthesize it?
Oh, so for us, we buy the compound. So we buy that. It's synthesized, by a company. It's not like a natural bile acid that you make by yourself. So when I was reading up on it, it's present in humans and bears. Is that correct? Yeah. So bears, that's they actually have places where they collect URSO from the bile of very certain types of bears. Yes. So that was the main source of it for many years. I think that that's still going on now. So, and presumably they were using it to help break down animal fat that they were eating. Right. Yeah. It's I don't know. It's kind of like an ancient, Asian type herbal medicine when they realized that this bile acid from bears had medicinal properties, basically. It's amazing. Yeah.
Aspirin is the same. There's many drugs that are based on or developed from ancient recipes of one type or another. How does it actually work?
So it can bind to different receptors. So, for example, like in if you have gallstones, so it can regulate cholesterol, and so it can help to break down the gallstones that are in there, basically dissolving them, and has anti-inflammatory effects as well. So it can act through different cytokines, chemokines. These are inflammatory mediators that that can be found in different tissues and different organs. And so usually when it wants to sort of suppress or maintain that immune response, it'll also use processes like phagocytosis. And it can induce, cell differentiation. It has just a multitude of effects once it's, introduced, depending, again, I know I keep saying that, kind of depending on the disease type, because we've seen such different effects from UDCA. So it's hard to say, oh, this is exactly how it works every single time, because what we're finding is that that's not always the case.
Inflammation. Do you want to just tell me what inflammation means?
So inflammation inflammation can actually be a good thing. So when you have an injury or you have wound healing or you get, stung by a bee, inflammation can then promote a healing response. And so you get the release of, growth factors and anything that sort of helps the tissues or the cells in a positive type way. But inflammation can also be bad. And so if you have a wound that won't heal, then you have ongoing inflammation, and you might see an increase in factors that will negatively impact that healing process, whether it's, a skin or a tissue wound, or if you're talking about the liver, like during liver resection. And so, that's some anti-inflammatories are kind of a big deal. And so, so the way we look at inflammation with regards to PSC is that, if you have an inflamed liver, bile duct, basically the cells are sending out or secreting different factors that can just increase that inflammation to a point where other things can be activated that can induce fibrosis, cirrhosis, et cetera. And so anything that can be anti-inflammatory in that situation can be looked at as a potential, therapeutic. And
one of the things that URSO does does it thin the bile acid so that it flows more freely through the sort of inflamed bile ducts?
It can. That can be one mechanism, yes, where it will allow that bile to flow, a little bit more easy because, having any kind of blockage in your bile ducts, especially long term, is going to have a very negative impact on the health of your liver and, of course, of your whole body. The basic function of bile is, you absolutely have to have it to be able to digest, but also absorb fat or any kind of fat derived vitamins that, are in your small intestine. So when you eat, you have that stimulation of different gastric acids, and then you have a secretion of bile, right? Most of the bile will be recirculated back into the liver. And so you have sort of an intrahepatic circulation is what it's called. You will eliminate some of those bile acids, through the feces. So some will go out, some can be stored in your gallbladder. But then the rest of it, I think about 75 or more % will be recirculated back up into the liver to be used again. And so the main cell type, of course, are the hepatocytes that make the bile acids. And, there's some conversions and some chemistry in there, but they get modified through the bile ducts by those cells. The cholangiocytes themselves modify the bile. And bile is incredibly toxic. It's not something that, you want to have hanging around, and cells don't like it either. So the cholangiocytes have to modify it, and they're also able to survive in that toxicity because they're right in close contact with the bile. Like for patients that don't, or for people that don't have a gallbladder, you have now removed your bile acid storage site. So that's also why sometimes people after the gallbladder removal, let's say they eat a big heavy meal. If you have a gallbladder, it'll stimulate a lot of bile acids because you've just eaten something, that's probably not super healthy for you, very, heavy or full of cream or butter or fried. And so if you have a gallbladder, a lot of the bile acids go get stored. The rest of them you lose in the feces, and then you have the intrahepatic circulation.
Is it advantageous to eat less things that stimulate more bile for somebody who has a failed or failing mechanism to recirculate it through the liver?
Yes, in my opinion, yes, absolutely. Because just like things that can, if we go back to the gallbladder, things that can trigger the gallbladder that can cause then gallstones, it's the same situation. I mean, so if you have any kind of a condition or disease where you're having issues with your actual bile ducts or bile flow, then probably it would be beneficial to eat a more healthy,
is that you also
diet.
Need enough protein to keep your body running, and your liver actually needs protein to actually fight the disease.
Sure, absolutely. Absolutely. I think you have to find that balance. You really do. And what we typically see with those bile ducts during an injury, and I'm talking about animal models, during an injury, is there's a response from the bile ducts where all of a sudden, instead of having like maybe 2 bile ducts per portal area, you have 5. And we call that, a hyperplasia proliferating state. And that's a response to a wound or an injury. And that's a normal response. But then it doesn't stop. It just continues until, you've gotten into a situation where you get the fibrotic scarring. You have like a cirrhosis type state, and then the liver can't function anymore.
So what happens is that in response to a bile duct being blocked, that other bile ducts grow in the liver. Is that what?
Exactly. Yeah, exactly right. So we call it ductular reaction.
What the basic studies say about URSO is that it reduces the symptoms, it reduces your liver numbers, but doesn't necessarily reduce the amount of time to transplant.
I would agree that is, I think that's the general understanding. And I think that might be maybe correct. There's this subpopulation of patients that will respond, but the response isn't that, you go in and the fibrosis might be decreased. That's usually not it. It is usually, I don't itch. I don't, maybe the pain is down a little bit. And I think they feel more managed, but I don't know that URSO is going to be that drug that's going to stop the need for transplantation. I mean, I would agree with that. Unfortunately, I think that it's not potentially the drug that they thought it might be originally.
Is it but from what I can gather, the only harm it can do is if it's over prescribed in a way.
Right, or overdosed. Right, not overdose. That's not if it's given at the wrong dosage. Yes, that. So I think there's at least one, if not 2 studies, maybe that came from Keith Linder's group that showed that really high dose of UDCA can be it can be very damaging.
So it can be.
They had a pretty good group too.
Carcinoma, is that right? Is that what the problem is with it?
Right, and so it can have. It sort of like has an opposite effect, because we've also done studies using UDCA in our tumor models, and we showed that the tumors were decreased. However, our doses were probably way different than what the human doses are, and for sure they were not nearly as high as what these doses are that can induce. I mean, I think that they had some patients that actually didn't survive this treatment. But again, I think you also have to think about each patient is so individual, and their condition, their disease state, all of that's going to be different from each other. And so, you might have an outcome that you didn't expect, but to only say that it was because of the high UDCA or low UDCA, that might be a stretch on interpreting your results, just because, I think you go back to let's say just diet. Well, were all of your patients eating the same way? Were all of your patients, was their lifestyle the same? Is their genetic makeup, similar? And if it's not, then I think it's kind of hard to generalize that. But saying that, I do think that staying away from that high dose UDCA is probably, that's, the physicians are exactly right about that.
What are your plans to, you're continuing this research? I mean, what are your areas of research going to continue in this area?
Right. So this last paper that we published, which has been a little bit of a controversy because we do show a protective effect in UDCA using both an animal model, but we had a few patient samples, not a lot. We had a few patients that were treated with low dose UDCA, and we were able to sort of look at those in just some genetic type situations to see that they were not expressing as many of the like inflammatory markers. So, we think it might be promising, but I think it might be more important to take UDCA and maybe combine it with something else. Maybe do a dual therapy. So where you're getting maybe URSO for the patient for those symptoms or for the inflammation, maybe to help with that, keep it at a very low dose, but then couple that with something else that has been shown to have a really direct effect on the liver. And again, I'm talking about, in the lab, not in patients. So some of the studies that we're doing besides the UDCA is we're using antihistamines. So of course, histamine is a huge inflammatory mediator. This is what causes the redness, any kind of, anytime you get a wound or a bite or whatever, you have an increase in histamine to that source. And so we treated some of our PSC models with just over-the-counter antihistamines that can block either, allergy symptoms or gastric secretion. And we had great results with these models. I mean, we had almost complete resolution of the fibrosis. We had complete resolution of serum enzymes. The total bile acids came down. And so drugs like that are readily available and a lot of patients are already taking at a very safe dose, combined with, maybe the bile acid, maybe URSO, maybe obeticholic acid or nor-URSO. I think that could have a real beneficial effect on patients, because I don't think that we can just continue trying URSO by itself in models. I don't think we'll see the results that we really want, but I also don't think that we're going to be able to convince the medical community, oh, you should, really focus on URSO, because I think they're also thinking, we've tried that. We're trying that. It's really not working. And so if we can convince them, to continue giving patients that if they need it, but then to add something else, especially something like the antihistamines that can target cholangiocytes and bile ducts themselves. Exactly. And so this can help reduce their reactivity.
Now, I've never heard of the use of antihistamines in the treatment of PSC before. Is this something that I just haven't heard of, or has it been,
Well, no, this is I would say it's relatively new. And so we published that paper earlier this year, and I'm super excited about the results. I think that something just as simple as blocking histamine, but you have to be careful. You can't block all of the histamine in your body. You need it. It's a necessary thing, especially for wound healing responses or any kind of damage. But this was just an idea that we had because we had done some work that showed that in patients with PSC, they for some reason have higher circulating levels of histamine in their serum. And so where is all this histamine coming from? And one of the players we think is heavily involved are mast cells. And so this goes back to immunology when we talk about mast cells that are just an immune cell that are made in the bone marrow. And again, they'll migrate to tissues when there's a damage. And so what we found is in patients with PSC or in our models of PSC in the lab, there is an increase in the number of mast cells that migrate to the liver when there's damage. And so once they're there, they release all this histamine. And so we've used different drugs to try to block that. We also treated our model with a drug called cromolyn sodium, which is an asthma drug that's used for patients as an inhaler. But we gave this, more directly into the body. But we saw the same results as we did with our antihistamines. When we blocked that histamine level with the cromolyn sodium, all of our mice were healthy again. The livers were back to functioning. Total bile acids are down. Fibrosis is down. And so for us, for my work, we think that histamine is going to be a really potential target. And one of the best ways to get at it is going to be through antihistamines that are already made. And there's so many to choose from. You can buy Allegra, you can buy all different kinds that are, the chemical synthesis behind them are all a little bit different. They do the same thing.
Well, I think that's the name of the game at the moment, isn't it? It's not, a complete cure might be a long way off, but if you're able to suppress the symptoms and prolong the use of the liver, then most people would be reasonably happy with a 70 or 80 year time span in their life. Yeah.
Sure. Absolutely. No, I totally agree with you. We also, in that study, since, as you know, a lot of patients that have PSC, unfortunately, have a greater risk to developing cholangiocarcinoma. I mean, this is something I think that weighs on their mind after they get the diagnosis of PSC. And so we used a model of cholangiocarcinoma and also treated that model with the H1 or the H2 blockers. And we were able to, I don't want to say ablate, but we were able to reduce tumor burden significantly. Those tumors really never had a chance, and inflammation was down. And so for us, that's pretty exciting. It's even if you could keep the patients manageable, but keep the risk of cholangiocarcinoma, knock that down, to where it's not something that they have to always constantly be having in the back of their mind worried about.
So H1 and H2 is histamine 1 or 2, is it?
Yes, right. Yeah. Histamine 1, H1 receptor blocker and H2 receptor blocker.
There's a lot of talk about the microbiome and the combination of the microbiome and the actual sort of physical illness, if you like. Is there any interest in that, or have you studied that at all? I have an enormous amount of interest in this. This is not something that I've started working on yet, but so for me, this is a huge area, and it is something I'm very interested in. And we haven't had a chance to even start looking at it in terms of our antihistamine treatments or UDCA treatments or mast cells. We know mast cells are involved in intestinal proliferation. So it is definitely going to be an exploding area. It's going to continue to be an exploding area. It's everywhere. If you've been to any of these big liver meetings, you see the huge sections on the microbiome and the gut-liver axis. As I say, I could talk to you all day about this stuff. I'd like to check back in with you again if I can, and certainly as you do these studies. Are you familiar with Rachel from who runs the patient registry?
Yes, I know her.
Great. Well, I'm sure you guys can chat. And obviously Ricky is a great resource for all of us.
Yeah, I love all of them. I feel so fortunate to have gotten connected with this group, and it's also put me in the loop with patients as well. I mean, of course, I don't offer any medical advice, but I like to hear their stories because it keeps me also focused on what I'm doing in the lab when I think about that. But it sometimes can spur ideas. If they all talk about something that's happening to them, then I'll say, okay, maybe, if we had some drug or something that we could use that might reduce this or reduce that. And so, for me, it's become kind of a personal mission, even though I don't have anybody close to me that has, PSC or actually any liver disease. So, but just being in contact with the PSC partners and then those patients and those groups has just it's a real driving force for the work that we're doing.
Wonderful. Well, thank you very much for your help, Heather. It's been wonderful talking to you. Unfortunately, there's still no known cure for PSC, so we will urge our listeners to recycle themselves and become organ donor. That's always a good way to help at the moment.
Absolutely.
But thank you very much for your help. We look forward to hearing more about your studies in the future. Bye-bye.
Bye-bye.
Well, I'm afraid that's all the time we have for this week. For more information about PSC and for a list of people and topics we'll be covering in the near future, please go to www.pscpartners.org. That's www.pscpartners.org. PSC Partners is a non-profit organisation dedicated to providing education and support to primary sclerosing cholangitis patients. There is information and resources on the website. There is a conference once a year. There is a private Facebook group that you can also join. Also, please join our patient registry. This is an anonymous database that provides research support to the medical community who are researching this disease. Thank you very much for listening.